Good morning, students.
Good morning, ma'am.
Am I audible? Am I audible to you?
Yes, ma'am.
Okay. If there is any if the connectivity, if it will lose, then please tell me. Okay, whether I am audible or not. So here I am going to start the last class problem which we have not covered. So can you see the screen? Screen visible, eh?
Yes, ma'am.
Okay. So last class problem, I'm going to continue that. Up to the MS diagram and MS by ER diagram, we have finished. Here you can see that due to the changing moment of inertia, the value of I, A to C, there is a constant value of I, and from C to D, the value of I is going to be changed. So the MS by ER diagram, you will get the MS by ER diagram. There will be change in the MS by ER diagram after plotting the MS diagram. So here you can see that you will get this composite section as MS by ER diagram, and this MS by ER diagram we will divide it into three portion. That is, we will get the first rectangle, okay, and then second section we will consider this as a triangle, and third section again you will get this triangle. So three section will be there, okay, as a MS by ER diagram, and from this point to this point, C point, you can see this is I, and from C to D it is 3I. Okay, so we have find out the moment of about this point A, which is 100 into 5, 500, and moment of C 100 into 2, that is this is 200. Okay, and then we have divided into, after plotting this MS diagram, we have plot the MS by EI diagram. So MS by EI diagram, you will get the MS by EI diagram. This will be your MS diagram. At this moment, the moment is 500, and this moment you will get the moment is 200. And at this point, point D, the moment is 0. This is point C. This is point A. So you'll get the MS diagram like this, and then we have divided into like this. Okay. So you'll get a three section here. This is first rectangle, this is second rectangle, and this is third rectangle. Okay. So then after this value is I, and from C to D it is 3I. Okay, and this is point B. So this is first section. So this is total is 500 by EI. This is total is 500 by EI. So this is 200 by EI. Okay, this is 200 by EI, and after that, as I is going to be changed here 3I. So this, for the third triangle, this value will become 200 by 3EI. So this you can see, this is 200 by 3EI. Okay, and this is total is 500 by EI, and this moment at this point is 200. So this magnitude will become 200 by EI, and after this point the value of I is going to be changed, that is 3I. So this magnitude will become 200 by 3EI. Okay, so for the rectangular section 1, the MS by EI value will become 200 by EI, and for triangular section 2, the MS by EI value will become 300 by EI. Okay, this will become 300 by EI, and this value for the third triangle, the value of this value will become 200 by 3EI, because I is going to be changed. Okay, now after plotting this MS by EI diagram, you have to locate the load. Okay, that is the P1, P2 and P3. So P1 is located at exactly at the CG of this given figure. So P1 is located exactly at a distance of B by 2 from point A. Okay, exactly P1 will located exactly at the center. And what will you, how you can find out the value of P1? That is area of the first rectangle. So area of the rectangle is B into H. Okay, so what is B? B is A to C. B distance is 3. So B is 3 and height is, it is 200 by EI. Okay, the calculations, I have given the calculation in the next step. Then P2 for second triangle, P2 will be located at a distance of B by 3. Okay, exactly at the CG of the given figure. And how you can calculate the value of P2? That is half into base into height, because this is a triangle. It is located at a B by 3 from this A, okay, from this corner, okay. And then P3 for third triangle, P3 you have to locate. So P3 you have to locate from this point to this point, okay, again. So from this to this, it is from this triangle to this, it is b by 3, okay, this is b by 3. So total distance will be 3 plus b by 3, which is equal to 3 plus b by 3, which is equal to 3.67. this small, यहाँ से यहाँ तक का जो डिस्टेंस रहेगा वो b by 3 रहेगा, which is equal to 0.67, which is equal to 0.67 plus 3, which will be equal to 3.67. So for P1, the b by 2, that is 3 by 2, it is 1. For P2, P1 it is 1.5, 3 by 2 it is 1.5, and P2 it is b by 3, that is 3 by 3 it is 1, and P3 the total distance will be, that is equal to 3 plus b by 3, 3 plus b by 3, okay. So that will be equal to 0.67, that will be equal to 0.67, so 3.67. And what is the x bar of the analogous column section? X bar of the analogous column section is 3.59, 3.59. Then after locating the P1, P2 and P3, okay, you have to find out the value of E1, E2 and E3. So for P1 is located from 1.5 from point A. So what is the eccentricity of this P1 about y axis? You will get, this will be the eccentricity of this figure, okay, this will be E1. Okay, so E1, how you can calculate the value of E1? E1 will be equal to x bar, that is 3 point. From y axis you have to find out the E1 of this P1, that is eccentricity of this this P1. So that will become, E1 will be equal to 3.59 minus 1.5. Then similarly E2, for second rectangle P2, the value of E2 will be equal to 3.59 minus 1. Okay, and both P1 and P2 are located to the left of y axis. So P1 and P2, the value of E1 and E2 will become plus, and P3 is located to the right of y axis. This dotted line you can see, this is y axis, okay. So this dotted line is nothing but y axis. So P3 is located to the right of y axis. So value of E3 will become plus. So how you can get, you'll get the value of E3. So E3 will be nothing but this distance. E3 will become this distance from y axis to up to the P3. So E3 will become, total is 3.67. P3 का लोकेशन है A से 3.67 पर, यहाँ से यहाँ तक b by 3 plus 3, that means 3 plus b by 3 will get 3.67. So E3 value of eccentricity for this P3 will be equal to 3.67 minus 3.59. You will get this distance, that is 0.008 and 0.08. And as this P3 is located to the right of y axis, the value of eccentricity E3 will be plus, and the value of E1 and E2, as it is located to the left of y axis, E1 and E2 will be minus. So this calculation is shown in the next step. You can see here in the properties of loading, after plotting the MS by EI diagram, the total load, that is equal to P1, that is equal to P1 plus P2 plus P3, which is nothing but area of MS by EI diagram. So that MS by EI diagram, after plotting this MS by EI diagram, we have located P1, P2, P3. So total load will be equal to P1 plus P2 plus P3, which is equal to, first section is your rectangle, second and third is your triangle. So height, so area is nothing but half into base into height. This will be half into base into height. This is again half into base into height. And as first section is your rectangle, so it is base into height. And what is the magnitude for first rectangle? It is 200 by E. It is minus. Okay, we got the moment is minus, so it is minus 3b into height, b into h, minus P2 half into base into height, minus half into base into height. So for first rectangle, the height is 200 by EF, and for triangle, height is 300 by EF. 500 minus 200 will get 300, and for third triangle, I is going to be changed, so it becomes 200 by 3 EF. Okay, if you solve this, you will get the total value of load. Total load is minus 1116.67. You will get this value. Then you will get the eccentricity of this loading. So eccentricity of the loading, E1 will be equal to This is 3.59 means x bar minus 1.5, you will get minus 2.09. Then E2 is 3.59 minus 1, you will get minus 2.59. Both are minus because it is located to the left of y-axis. It is located to the left of CG or left of y-axis. And this value is plus because it is located to the right of y-axis. It is located to the right of CG, so it is plus. This value E3 is plus. Okay, so you got the value of E1, E2, E3 for the load P1, P2, P3. E1, E2, E3 is nothing but eccentricity, or we can say the perpendicular distance of that load up from the y-axis. So as we have located this load P1 from A, corner A, we know the location of that P1, which is located from A is 1.5. The remaining distance, how you can calculate? By subtracting it from x bar. So x bar minus 1.5. Why we have taken it minus? Because it is located to the left of CG. So E1, E2 and E3. Then after finding out E1, E2 and E3 value, you will get the MYY which is equal to P into E, that is force into the perpendicular distance. So again My1 plus My2 plus My3, which is equal to P1 into E1 plus P2 into E2 plus P3 into E3. P1 into E1 plus P2 into E2 plus P3 into E3. You will get that value. Okay. Then after that, after finding out this value, what we have to calculate? You have to calculate the this basic equation of, after the plotting that, use the basic equation of the column analogy method and put the value of that method, values of force and area, all the values you have to put in that equation. You will get the indeterminate moments. You will get the indeterminate moment, that is Mi. So value of load is minus 6.67 divided by the total area. Total area, this is the area of the analogous column section. This is the total load just now we have calculated. Plus, we are taking this plus, this MYY, that is moment about y-axis, just now we have calculated that, and the moment of inertia, then and the moment of inertia about this y-axis. This is again the moment of inertia of the analogous column section. So all the values you have to put in this equation. You will get the equation in terms of x. Okay, that is minus 209.5 plus 61.04 into x. You will get that value. Then find out the indeterminate moments. Then find out the indeterminate moments at A and B, that is MIA, which is equal to minus 209.51 plus 61.09, then minus 3.9. How you will get this value minus 3.9? Just in one line I will show here. This is point A, and either you can draw it on the analogous column section, or simple line you can show. And this is the y-axis we are located. This is the y-axis we are located. So this is x bar of the given figure, which is equal to 3.59, which is equal to 3.59. Okay, and the total length of the beam, which is equal to 9 meter. It is 9 meter. Okay, so as you can say that this is the CG of the analogous column section, and MIA means MIA here, MIA at x is equal to, you have to put the value of x here. Okay, so from CG at what distance the point A is located? It is located at a distance of 3.59. X means, to find out the indeterminate moment at A, always the x value will be equal to x bar. Always the value of x is nothing but x bar. Okay, about y-axis x bar hi rahega. But as the A point is located to the left of the CG, the value of x will be negative. So we have put it negative, but it is always x bar. Okay, and how you will get MIB at x is equal to here. So MIB at x is equal to here, that is for total length of the beam is 9 meter. So 9 minus 3.59. So you will get this distance. So this distance will be 9 minus 3.959, that is equal to 5.41. And as this point B is located to the right of this CG, this sign conventions we are using to put the value of x. So as this point B is located to the right of CG, the value of x will be 5.41. Okay, so just you have to put this value in the equation here. You'll get the indeterminate moment at A moment at B. You'll get the indeterminate moment at A and indeterminate moment at B. Okay, then after that you can find out the final moment, that is M is equal to ms minus mi. So ma is equal to msa minus mi a, and mb will be equal to msb minus mib. Okay, so ms is nothing but msa and msb. These are the statically determinate moment at a and b, and mia and mib, these are the statically indeterminate moments at a and b. So which is nothing but this. So using column analogy equations, you will get the indeterminate moment. Okay, using the column analogy method or equations, where we will be able to find out the indeterminate moment, not the determinate moment. And how you will get the determinate moment? By plotting, by making the structure as determinate, and after plotting the ms diagram, you will be able to find out the msa and msb value. You will be able to find out the value of msa and msb. So how you can find out this msa and msb? Msa means statically determinate moment at a, and MSB is statically determinate moment at B. Okay, so MSA and MSB. So you can see this is a MS diagram we have plotted here. After making the structure as determinate, we have plotted this MS diagram. So what you want to find out here? This is point B. This support we have removed. Okay, after the indeterminate structure, this support we have removed. After remove this support, we got the determinate structure, and then we have plotted the MS diagram. MS diagram is nothing but the simple the bending moment diagram. So bending moment diagram, we got the moment of this 100 kilonewton at point A, 100 into 5, which is 500. Okay, we got this moment is minus, and 100 into 2, this moment is 200. Okay, minus 200. So what you note down here? So after plotting the MS diagram, here in this step itself, you note down the value of MSA and note down the value of MSB. Okay, so what is the moment value, or what is the statically determinate moment at A, and what is the statically determinate moment at B? Yes, am I audible? What is the statically determinate moment at A? Statically determinate moment at A and statically determinate moment at B. What is the statically determinate moment at A, MSA, and what is MSB? Yes, am I audible or not? Am I audible?
Yes, ma'am.
Am I audible?
Yes, ma'am.
What is MSA and MSB? Statically determinate moment at A, or simply we can say the moment at A and moment at B. After plotting this bending moment diagram, what is the moment at A and what is the moment at B?
Ma'am, 500 and 0.
Yes.
Five hundred and 0.
What is the moment at A? Statically determinate moment at A, MSA and MSB.
MSA A equals to 500.
The moment at A is it is minus 500. The moment at A it is minus 500, and moment at B it is 0. Okay, moment at A it is minus 500 and moment at B This value you will get from MS diagram. After plotting the MS diagram, you will get this value. So MSA is minus 500 and MSB is 0 and MSA minus MIA. So minus 500 minus of minus 428.64, you will get minus 71.36, and MB, that is MSB minus MIB, you will get 0 minus 120.71, which is equal to minus 120.71. So this is how we can find out the bending moment values of MA and MB. After plotting this moment, after finding out this final moment, you will be able to plot the bending moment diagram. So here both the value of moment is minus, you will get this hogging moments are negative and the sagging moments we are considering as positive. So this is how we can plot the shear force and the bending moment diagram. Either you can plot this net bending moment diagram, you find out the reaction, you have the moment, you find out the reaction RA, you find out the reaction RB. After getting these reactions, you can plot the shear force diagram and you can plot the bending moment diagram. Either you can plot the bending moment diagram like this. The bending moment at A is 71.36 and bending moment at B is which is 120.71. So this is your end moment diagram. Okay, and as this is a point load, okay, so you will get this moment. This will be your free moment diagram or support moment diagram. Okay, so this value will be equal to WAB by L. This is equal to WAB by L, total ordinate, and this moment value is, this is end moment value. This is 71.36 and this is 120.71. Okay, so this moment is negative, which I have shown here, and this is your net bending moment diagram. So here I have calculated this net bending moment value, and this WAB by L, you will get this total moment, okay, under this load. Okay, so this is, either you can plot, this will be your final bending moment diagram. Okay, and this is this diagram I have shown, it is a net bending moment. This is a net bending moment, means this moment is net bending moment diagram. So this net bending moment, you can find it out. You are having the reactions, you find it out with the help of this reaction, and you will get this net bending moment value, and this is your end moment diagram. So this is how you can plot the shear force diagram and the bending moment diagram. Okay, then I will start. This is a new type of the problem. Here you have to find out the carryover factor and the stiffness factor. You have to find out the carryover factor and the stiffness factor. Okay, so here in this type of the problem, there will be no external loading is given in your structure. Only what you have to find out, you have to find out the stiffness at A, and you have to find out the carryover factor from A to B and from B to A, stiffness and carryover factor. Okay, for the given beam, for the given fixed beam. So stiffness at A, it is denoted by Ka, and carryover factor from A to B. These two factors you have to find out. Okay, and similarly at B, you have to find out the stiffness at B and carryover factor from B to A using the column analogy method. Using that equation, that is Mi, indeterminate moment, you have to use that equation, and with the help of that equation you have to find out the indeterminate moments at A and indeterminate moments at B, which will give you the value of stiffness at A and stiffness at B. So here what you have to keep in mind, that the stiffness at A, which is nothing but always the indeterminate moment at A. Okay, indeterminate moment at A will be equal to stiffness at A, as we will apply the unit rotation. You will get the stiffness at A, which is equal to the indeterminate moment at A, and stiffness at B, which is equal to indeterminate moment at B. So these two values you have to find out, indeterminate moment at A and indeterminate moment at B, using the column analogy equation. This is your column analogy equation, which is equal to P by A plus M by Y divided by I by Y into X. This is your column analogy equation. So using this equation, you have to find out MIA at X is equal to and MIB at X is equal to. So to find out this value, you need to find out the load, area of the analogous column section, moment of inertia, and the moment about y axis. Okay, so for that, here as there is a no external loading, we'll apply the load is equal to P equal to 1. We will apply the unit load, and with the help of this unit loading, we'll find out the stiffness at A and stiffness at B, MIA and MIB. That value, after finding out this value, you will get the stiffness at A. So for that, again the steps are similar as we have done in the analysis. Here this is a given beam, no external loading is there, because there is no need to plot the MS diagram, no need to plot the MS by EI diagram. Only here you have to get the value of stiffness and carryover factor, you need to draw the analogous column sections and you have to apply the load as a unit load. Okay, so first of all we'll plot the analogous column section. So what is your analogous column section? Again, the analogous column section is nothing but the length of the member will be same as the given length, means this beam you have to represent as the analogous column section. Okay, so how you can represent this beam as an analogous column section? Analogous means similarity, similar section you have to plot. But what is the meaning of this analogous column section? Where the length will be same as the given beam. So length is total 8 meters. So length will be kept as constant, but the width, whatever the width here, width A to C the width is 2I and C to B the width is I. So this width will be equal to 1 by EI diagram. So this width will be 1 by EI, means A to C the width will become 1 by twice EI and C to B the width will become 1 by EI. So accordingly you have to plot the analogous column section. Okay, so this analogous column section, as this width will become 1 by twice EI, so this is 1 by 2 and this width will become 1 by EI. So 1 by 2 ratio is 0.5 and this 1 by 1 ratio is 1. So naturally this width will be less than this. So accordingly you have to see that ratio and accordingly you have to plot the analogous column section. So here I can plot the analogous column section. So from A to C the width will become 1 by twice EI. So this will become 0.5. Okay, and from C to B the width will become 1 by EI. So naturally this width, from B to C to B the width will be more. So this will be 1 by EI. This width will become exactly opposite to the given section. Exactly opposite to the given section. So this width will be 1 by twice EI. जितना भी EI है आपका यहाँ पे 2I है, so this will become 1 by twice EI. Okay, and this width will become 1 by EI. So 1 by twice EI and 1 by EI. Okay, 1 by twice EI, this is 0.5. So this ratio is naturally less to this 1 by EI. So this is 1. Okay, so this is 1 by EI diagram, which is exactly opposite to your given section. Length will become same. This length from this to this, the length will be 4 meter, and this to this, the length will be same as 4 meter. But only the width of the given section will get change, which is equal to 1 by EI. That's why this analogous column section is also called as the 1 by EI diagram. This analogous column section is also called as the 1 by EI diagram. So after plotting the analogous column section, what you have to find out? You have to note down the property of the analogous column section. Okay, so here you can see that after plotting the analogous column section, okay, we have divided into two parts. You will get the two rectangle. Whatever the section you will get, that is the composite section. So we have to divide into two parts. So this will be your first rectangle section and this will be your second rectangle section. Okay, so then after that, what you have to do, and this width you can see 1 by twice EI, and this width will be equal to 1 by EI. So width ke according we have to plot this analogous column section. Two sections we got. So after that, after plotting this analogous column section, what the properties we have to find out? We have to find out the area of this section. This is given composite section. We have to find out we have to locate the CG of this given section, and we have to find out its moment of inertia about y axis. Okay, so for that, area of the analogous column section, it is always L into 1 by, and this is the rectangle section. Area of the rectangle section is base into height. So it is base is 4 meter, height is 1 by EI. Okay, 1 by EI, that is L into 1 by EI will be your area of the analogous column section. L into 1 by EI will give you the area of the analogous column section. So the first area A1 plus A2, the area of the first section, it is equal to 4 into 1 by twice EI, which is equal to 4 by twice EI, plus area of the second section, that is 4 by EI. Area of the second section, that is 4 by EI. This is area of the first section, 4 by twice EI. So total area of the analogous column section will be equal to 6 by EI. Total area of the analogous column section is 6 by EI. Then location of CG. You have to locate the CG of this given figure. Okay. So what is the CG of the given figure? Centroid you आपको locate करना है. So that is nothing but again summation AX by summation A. That is the total area of the given figure. So that is nothing but A1 into X1 plus A2 into X2. So for section 1, what is the CG of the first rectangle from A? This point you have to take as a reference point. This point as a reference point you have to consider. So for section 1, what is the CG? Section 1 exactly at the center, so 2 meter. And for second rectangle, what is the CG from this reference point? CG from this reference point, this total distance. So that will be the total this 4 plus 4 by 2. 4 plus 4 by 2 CG of this. So this will be X1, this will be X1 and this will be X2. Okay. So X1, X2. So this is how you can find it out, this A1 into X1 plus A2 into X2 divided by the total area. So after calculation of this, the total CG of the given section is 4.67. Once you get the CG of the given section, locate YY axis. So this is the CG of the given figure X bar about the YY axis, which is 4.67. Means just after this point C, this YY axis will be located. Okay, this is total 4 meters. So after 4, this X bar is 4.67. So after from A, the CG of the given section is 4.67 from A, and from B, this is your end point. From B, how much it is? Total 8. So 8 minus 4.67, you will get 3.33. This is 8 minus 4.67, you will get 3.33. So the A point is located from YY axis. The A is located 4.67, which is nothing but always X bar. And B will be total length minus X bar. You will get the location of B, that is 3.33. Okay. So this is how we can find out the properties of the analogous column section, that is area of the analogous column section, location X bar, and then we will find out the moment of inertia about the YY axis. Moment of inertia about YY axis. Again, to find out the moment of inertia, you have to use the parallel axis theorem. So what is your parallel axis theorem? Parallel axis theorem, that is Iy1 plus Iy2. So that is nothing but Iy0 plus area into distance square. But as you have to find out this moment of inertia about the centroidal axis. This YY axis is not the reference axis. This is the centroidal axis. So from the centroidal axis, you have to find it out. So that will become just you write down this if you don't know how to find it out. So that Iy1 will be equal to Iy01 plus A1 into X bar minus X1 whole square. A1 into X bar minus X1 whole square. Iy01 is nothing but moment of inertia of rectangular section about Y axis. Okay, about the centroidal axis. Y axis है, so it is always dB cube by 12. About X axis it is BD cube by 12. About Y axis it is dB cube by 12 plus A1 into X bar minus X1 whole square, plus for second section it is Iy02 plus A2 into X bar minus X2 whole square. So Iy1, Iy01 D. What is the D here? D in the analogous column section. What is the value of D? D is nothing but this. This is the value of D. And what is the value of B? B is nothing but base, which is nothing but length, 4 meter. Okay. So D is 1 by twice EI into D into B cube by 12. So this is D. Okay, that is width, and this is base. So dB cube by 12 plus area A1 2 by EI into X bar, this is X bar minus X1. CG of the first rectangle is 2. So X bar minus X1 whole square, plus similarly Iy02, that is a D. For second section, D is 1 by EI into B cube divided by 12 plus area EI. Area A2 is 4 by EI. Here you can see into X bar minus X2 whole square. X2 CG of the second section, it is 4 plus 4 by 2, that is 6. So once you solve this, you will get the moment of inertia about the YY axis, which is equal to 29.33 by EI. यहाँ तक आपका problem पूरा same रहेगा as we have done in the analysis. Okay, what is the? There is no need to find out the degree of static indeterminacy because there is no need of plotting the determinate structure, no need of MS by EI diagram. In which type of the problem? Where it is asked to find out the stiffness and the carryover factor. Stiffness factor and the carryover factor. There is no need of plotting the MS diagram, MS by EI diagram, and no need to calculation of the degree of static indeterminacy. step of the calculation is that you have to plot the analogous column section exactly opposite to this 1 by ER diagram. Then note down the property of the analogous column section, area, x bar and IYY. Once you note down this value, the next step will be that you have to find out the stiffness at A and stiffness at B. Okay, so the step number 4, just this will ये नहीं होगा determinate structure. So in the step number 4, yes, I'm audible. Yes, I'm audible.
Yes, ma'am.
यहाँ तक समझ में आया? यहाँ तक समझ में आया?
Yes, ma'am.
Okay.
Yes, ma'am.
Yes, ma'am.
So I'll continue after that. So after finding out this, what you have to find out? You have to find out the stiffness at A, that is denoted by Ka, and carry your factor from A to B. So simple as that. As there is a no external loading, as you have to find out the stiffness at A, that is Ka. So at this point A, we will apply the unit load, okay, in the vertical direction. So P is equal to 1. We'll apply the unit load at A. If you want to find out the stiffness at A, apply the unit load at A. If you want to find out stiffness at B, apply the unit load at B. But here, first we will find out stiffness at A and we'll find out the carryover factor from A to B. So for that, we'll apply the unit load is equal to 1. That is P is equal to 1 at A. And this is the YY axis we have located. This is the CG that we have shown in one line, or we can show it on the analogous column section. Simply on the one line we can show it on here. So this is the location of CG of the analogous column section, that is 4.67 distance से locate हुआ है from point A. So P we have applied equal to 1 at A. Okay, so this is as we have to find out the stiffness at A. We have to find out the stiffness at A. We'll apply the load at A. So then after, note down the properties of the loading. So what is the property of the loading? In the properties of the loading, what we are doing, we are locating the P and we are finding out its position. So where we have located P, where we have applied the load at A, because we have to find out the stiffness at A. How much load we have applied? We have applied P is equal to 1. We have applied P is equal to 1 in the vertical direction. So in the first thing, what is your total load? What is the load value? P is equal to 1. Total load ho jayega 1. As there is a no external loading, we'll assume the load is equal to 1. So total load will be equal to P equal to 1. Then you have to find out the eccentricity of this loading about loading from CG. So this is CG. CG matlab from YY axis. You have to find out the eccentricity of this loading. So this is nothing but the eccentricity of this loading. This matlab P equal to 1, इसकी लोडिंग, इस लोडिंग की इसेंट्रिसिटी आपको YY एक्सिस से निकालना है, which is nothing but E and which is nothing but X bar. Which is nothing but X bar, because we have applied the load at E. We are not located in the middle of here. इसके पहले के प्रॉब्लम में वो अपन exactly वो आपका जो भी given figure रहती थी उसके exactly CG पे locate करते थे, लेकिन यहाँ पे exactly we have considered the P equal to 1 at A because we have to find out stiffness at A. So eccentricity of this loading about YY axis or from CG will be equal to denoted by E, and which is nothing but X bar. Okay, so how much it is? Eccentricity of loading, it is E, which is equal to 4.67. X bar, which is nothing but X bar. But why it is minus? Because point A is located to the, यहाँ पे eccentricity calculation के लिए whenever we are calculating the eccentricity, the sign convention will be left and right. These sign conventions you have to follow. Okay, so your load is located to the left of CG, or we can say that the eccentricity of this located is to be located to the left of CG. Hence your value of E will be minus, and if your P is located to the right of CG, or eccentricity is located to the right of CG, the value of E will always be plus. The value of E will always be plus. But यहाँ पे the load or eccentricity of this loading y axis से मतलब x bar ही रहेगा. But why we have considered it is minus E is equal to minus 4.67 because it is located to the left of y axis. Okay, so this sign conventions you have to keep in mind. Don't make any mistake here. If for calculation of eccentricity, always we are following this sign convention. See that in which side your value of P or your P or E is located. If it is on the left side, take it minus. If it is on the right side, take it is plus. So E is equal to minus 4.67 and which is nothing but x bar. Why x bar? Because P is located exactly at A. So it is x bar. From CG से आपको eccentricity locate करनी है. किसकी? Eccentricity of this load. Total load. Total load कितना? 1. Then we will find out the moment of inertia about y axis. So what is the moment of inertia about y axis? Which is nothing but force into the perpendicular distance. Here you don't have to use the sign conventions of clockwise, anti-clockwise. Okay, your sign conventions will be left of CG, right of CG. Whether the force will be in the upward direction or the downward direction, the sign conventions will be for eccentricity, location of P, rightward or leftward. So only you have to take the magnitude, that is force into the perpendicular distance. So moment about y axis, किसका moment लेना है अपने को? P का moment लेना है. P का moment लेना है about y axis. So P into E, force into the perpendicular distance. So P is equal to 1 into minus 4.67. 1 into minus. Don't make any mistake here. Don't put the value of E is plus 4.67. You'll get the wrong answer. Why? Because you have to follow the sign convention, left side minus, right side plus. So you'll get the moment of moment about y axis. Moment of this P about y axis, which is equal to minus 4.67. So you are having the value of P, you are having the value of E. You can find out M Y Y. Okay. So what is this change here? Okay. After finding out the properties of the analogous column sections, in next step, what we are doing to find stiffness at A and to find out carrier factor. What we are doing, we are applying the unit load. Where we are applying the unit load? At A. Then we are finding out the properties of loading. Means we are locating P and we are finding out its position from y axis. So total load is always P equal to 1. In case of stiffness calculation, total load P equal to 1, where you have to find out the stiffness. Generally it is asked to find out at the end A and B. Then eccentricity, then MYY. Then next step, use the basic equation of the column analogy. Use the basic equation of the column analogy, that is P by A plus M plus minus A. We are going to take the maximum value of indeterminate moment. So P by A plus MYY by IYY into X. Then put the value of P here. P is equal to 1. Then area of the analogous column section 6 by EI plus MYY, it is minus 4.67 divided by moment of inertia about y axis of the analogous column section 29.33 by ER. Then after solving this, you will get the indeterminate moment at you will get the standard equation of indeterminate moment, which is in terms of EI. You will get it in terms of EI. Then find out MIA and MIB. Then find out MIA and MIB. So MIA, here you have to put the value of X. So again I told you that what is the value of A and B. So here already it is to be drawn. Again I will show it you. This is y axis of the analogous column. Here point A is located to the left of Y and point B is located to the right of Y. Okay. So this is plus. This value will be plus, and this is X bar of the figure. Okay. Always to put the value of X when you find out MIA, always it is X equal to X bar of the given section. Okay, 4.67, and this will be your value of B, which is equal to 3.338 minus 4. Length, total length minus 4.67. So X की value रहेगी यहाँ पे MIA at X. A आपका y axis से कितने distance पे located है? 4.67. Y minus because located to the left of CG. So minus 4. So this value you will get 0.909 EI. Then MIB at X is equal to B point is located from y axis at a distance of 3.33. Y plus because located to the right of CG. So we have considered this value is plus. Okay. So by putting the value of X here in this equation, you will get the MIA and MIB. After calculating this, after using the basic equation of column analogy, find out indeterminate moment and indeterminate moment at A and indeterminate moment at B. You'll get this value. Okay, uske baad your answer will become, what is your answer? Your answer will be stiffness at A, which is nothing but Ka, which is nothing but MIA. Stiffness at A is nothing but indeterminate moment at A, MIA, which is equal to Ka. Okay, so that the value of stiffness will be 0.909 EI. Stiffness at A is nothing but indeterminate moment at A. So this is value of stiffness. Okay, in terms of stiffness, in terms of EI by L, you just multiply this value into L. So 0.909 EI into L by L. So you'll get this value in terms of EI by L. So 0.909 into L, L is 8, length of the beam is 8 meter. So 0.909 into 8 into EI by L. If you want to find out the value of stiffness in terms of EI by L, you'll get this value 7.272, 0.909 into 8 into 8, or your answer will be this also. Okay, in terms of EI by L, you multiply this value into L, and in terms of EI, the value of stiffness will be 0.909 EI. So this is the first answer where this you'll get the stiffness at A. Then carryover factor from A to B. You have to find out the carryover factor from A to B. So just this formula you have to use, that you have to take in mod. Okay, so carryover factor from A to B. So formula will always be A to B है, इसीलिए ये जो अप्लाइड मोमेंट है और जो कैरी ओवर मोमेंट होता है, जैसे ए पे अप्लाइड मोमेंट है MIA और MIB is the carry over moment. Okay, so always your carry over factor will be equal to the carry over moment divided by the applied moment. So that is equal to MIB divided by MIA. A to B है तो पहले MIB carry over moment divided by the applied moment. So MIB divided by MIA. What is the value of MIB? That you have to take in mod. So MIB is equal to 0.362 EI, MIA is 0.909 EI. So you just take the ratio of this, okay, 0.362 divided by 0.3909, EI will get cancelled. So what is your carryover factor from A to B? It is 0.398 from A to B. So this is your two answer, the value of stiffness at A and value of carryover factor at A. This we got the answer for first part, stiffness at A and carryover factor from A to B. So stiffness at A, the value of stiffness is either 0.909 EI or 7.272 EI by L. And what is the carryover factor? 0.398 at point A and B. So this is the answer for the first part, stiffness at A and carryover factor from A to B. Then the next step, what you have to find out? Stiffness at B. Stiffness at B, which is denoted by KB. Okay. Then next step, you just erase this. There should no determinate structure. Directly in the step number 5, there will be you have to find out stiffness at B, that is KB, and carryover factor from B to A. Now the stiffness at B means KB आपका मिलेगा. For that again you have to find out the indeterminate moment MIA and MIB. So what is your stiffness at B and carryover factor from B to A. Okay. So to get the stiffness at B, what you have to do? You have to apply the unit load at B. You have to apply the unit load at B, that is P is equal to 1. Again the same process you have to repeat. Only the change is that you have to apply the unit load at B, which is equal to 1. Okay. Then again you are having this distance A, about y axis 4.67, remaining distance total is 8 meter. So 8 minus 4.67, this will be 3.33. Now what is the eccentricity of this loading? Okay, then after applying the unit load, we are finding out the properties of loading, means we are finding out the value of P, we are finding out the value of E, and we are finding out the value of MYY. Okay, so what is the value of P here? What is the value of P here? Yes, am I audible? Yes. Am I audible? Am I audible?
Yes, ma'am.
का आवाज ही नहीं आ रहा है आज.
Yes, ma'am.
Okay. What is the value of P? What is the value of P when we are applying the load at B? What is the value of P? What is the value of E? Eccentricity. When we will apply the load at B, P equal to P we are applying is equal to 1. So P equal to 1. Eccentricity of the loading will be equal to the distance of this B from y axis. Okay, so that you have to calculate from x bar. As you know, the value of x bar is 4.67. So total length minus 4.67, you will get 3.33. You will get 3.33. Okay, so here you can see we'll apply the load at B equal to 1, P equal to 1, then P will be equal to total load will be equal to 1, total load is equal to 1, then the eccentricity will be nothing but this much distance. This will be your eccentricity of the loading. So how much eccentricity is? E is equal to 3.33. Okay, whether you have to take it plus or minus, you have to take it plus because B is located to the right of CG. Okay, B is located to the or P is located to the right of CG. So eccentricity will be plus. As this eccentricity यहाँ पे left of CG में है तो we are taking minus, but your P is located to the right of CG. Okay, this is the CG, so it is plus. So E will be plus 3.33, and then we will find out M by Y, which is equal to P into E, which is equal to P into E. Okay, so you can find out this calculation just now I have shown you. P equal to 1 because we have applied the load at B, which is equal to 1. E is plus 3.33 because located to the right, and then we'll find out M by Y, force into perpendicular distance. 1 into 3.33, you will get 3.33. Then use the column analogy equation, P by A plus this, put all this value, you will get the equation in terms of X, 0.167 EI plus, then find out indeterminate moment at A, indeterminate moment at B. So what is indeterminate moment? So MIA at X, what is the value of MIA at X? It is always X bar. It is always X bar, which is equal to 4.67. But why minus? Because located to the left of CG. A point is located to the left of CG. That's why we will consider it minus. Then MIB at X is equal to. Okay, so it is total distance minus this will be plus 3.33. As it is located to the right, the considered is plus. So you just put the value of X in this equation, you will get indeterminate moment at A and indeterminate moment at B, which is equal to minus 0.360 EI and 0.543 EI, minus 0.360 EI, 0.543 EI. Then after finding out this indeterminate moment at A and B, your answer will become find stiffness at B. This is, just make it correct here. This is stiffness at B. Okay, that is denoted by KB. So what is the value of stiffness at B here? What is the value of stiffness at B? Which is nothing but MIB. B पे stiffness निकालना है, यानी जो indeterminate moment at B पे मिला वो होगा stiffness at B, that is 0.543 EI, 0.543 EI. Then stiffness again you just find it out in terms of EI by L, so multiply it with L. So 0.543 into 8, you'll get 4.344 divided by EI by L. Then carryover factor from B to A. As the carryover factor you have to calculate from B to A, it is equal to MIA divided by MIB. Okay, MIB will be the applied moment. Okay, as we are finding out the stiffness at B, so this is the carryover moment divided by the applied moment. So B पे load apply किया है तो B पे applied moment रहेगा, MIA will be the carryover moment. So MIA divided by MIB. B to A है और A to B रहता तो MIB divided by MIA. So MIA value is this. MIB you have to take in mod. You just find out the ratio of this. The answer will be 0.662. Carryover factor from B to A is 0.662 at point B to A. So this is the second type of the problem. Okay, where you have to find out stiffness at A and stiffness at B. Just you go through this problem. It's very easy. Only what the change is that only instead of external loading there is no loading. Only at A and B you have to apply the unit load. So P you have to consider it as 1. Okay, remaining will be as it is. Then you will get the answer stiffness and the carryover factor at both the point A and B. Okay, so there will be nothing, no change in such type of the problem, because only you have to find out the stiffness and the carryover factor. What will be the change is there? Only the this is the 2-span beam problem I have considered. Maybe it may be the 3-span beam problem. Okay, 3-span रहेगा, but उसमें change क्या रहेगा? Change only रहेगा कि आपका एनालॉगस कॉलम सेक्शन change होगा. Okay, but remaining calculation will be same. Nothing will be different there, because either it may be 3-span beam, but आपको stiffness at A निकालने के लिए A पे point load लगाना है, और stiffness at B निकालने के लिए B पे point load लगाना है. Okay, only the change will be there. There will be the change in the analogous column section. So either it may be 2-span or 3-span problem. The step of the problem will be same. Similar type of the problem will be asked, stiffness at A and carryover factor. Okay, so this is the second type of the problem. The first type problem will be analysis of fixed beam, and second type of problem will be calculation of these factors. Okay, so this is the end of this unit number 4. Okay, so here I will stop. You just I will upload these notes on your classroom. Okay, you just go through the notes and try to solve the problem. Okay, I will give the quiz today. I'll not uploaded it. I will upload it on after some time. So all of you have to attempt that quiz. Okay, your attendance will be marked based on that quiz. Okay. You can leave the class. You can leave the class, students. As I'm audible, you just leave the class. I'll take the. I'll give the quiz. Okay. I'll give the quiz, and attendance will be marked on the basis of quiz.